Well, hello, my friends. This is Rusty Waller with the American University of Ras Al Khaimah, and we will continue our journey through the valley of the shadow of probability theory. In this little video, we're going to examine an introduction to probability theory. Up to now, we've been looking at the language of probability, examining sets and descriptions of sets and so forth. We begin this with the idea of a probabilistic model. A probabilistic model is a mathematical description of the likelihood of a given event. It is a plan by which we are able to arrive at the likelihood of a given event. That is a probabilistic model. Probabilistic models involve an underlying process called an experiment, and that experiment will produce one of several outcomes. The experiment may be described as a test under controlled conditions. The set of all possible outcomes is called the sample space, designated by the capital letter omega. The set of all possible outcomes is called the sample space. Now, as we've seen in previous videos, it's easier to represent this with a Venn diagram. We have here a Venn diagram of a sample space. This is the universe, the set of all items in the sample space. So the sample space is the set of all possible outcomes. We will conduct an experiment. The set of all possible outcomes will be the set of all events that take place. An event is one outcome in the sample space of all possible outcomes. So we have an experiment, we have a sample space, now we have an event. An event is a subset of the sample space. In this particular diagram, we have an experiment, and it's a probabilistic model or plan. The experiment maps us into a sample space made up of everything, omega, and in that sample space, we have some subsets, event A and event B. This is the set, omega is the set of all possible outcomes, might be called the sample space, the universe. And in this, we have events that are subsets of that sample space. The probability law assigns a non-negative number to an event that encodes the likelihood of the event occurring. Let me repeat that. The probability law assigns a non-negative number. In other words, the number is positive, a non-negative number, to an event that encodes the likelihood of the event occurring. The probability of event A is denoted as the probability of A. That's how this is read. The probability of A is a non-negative number that encodes the likelihood of the event A occurring. Let me draw you a picture. In this picture, again, we have the sample space. We have an experiment that may lead to one of two events, event A and event B. The probability of A is the likelihood of event A occurring, and the probability of B is the likelihood of event B occurring. Now, the probability is always a non-negative number between 0 and 1. In other words, 0 is less than equal to the probability of A, which is less than or equal to 1. The probability of all is often given as a decimal or a percent. Here is the probability of 0. Here's the probability of 1. And the probability of A rests between the two of them. Sometimes we talk about probability in terms of percent. 0 is 0%, 1 is 100%. We might say that a probability lies between 0.0000 and 1. We might also say that a probability lies between 0% and 100%. Now, a probability of 0 includes none of the sample space. In other words, the event has no probability whatsoever of occurring. The probability of 100% includes all of the sample space. The events of a sample space must be mutually exclusive. Mutually exclusive means that the events are different and distinct. In other words, we have this. Event A is completely different from event B, therefore they are mutually exclusive. Event A is not the same as event B, and event B is not the same as event A, therefore they are mutually exclusive. Here, event A and event B are not mutually exclusive. Event B is included in event A. The problem with this is that we conduct our experiment, it leads us here, we don't know which one it's referring to. So we must have, for us to be successful, we must have mutually exclusive events so that we can identify distinctly which event occurred. And when we have this situation, we do not know which event occurred. Events should be mutually exclusive. And if they're not mutually exclusive, we just do not know which one of these it's referring to. The events of a sample space must also be collectively exhaustive. Collectively exhaustive means that all possible events are found in the sample space. Set event A and event B are collectively exhausted. Event A, B, and C are not collectively exhaustive because event C is not found in the sample space. Now, in this video, you have a couple of things you need to remember. First of all, this symbol. This is read as the probability of event A. This will be a number between 0 and 1, a positive number between 0 and 1. There are some terms to know. Probabilistic model. You had experiment that you need to know and understand. Experiment being a plan, an outcome. We talked about sample space. We talked about event. We talked about probability law, which assigns a probability, a non-negative number to a given event and outcome of a given event to C represent the likelihood of it happening. Mutually exclusive means that they are in the sample space but that they do not overlap at all. And collectively exhaustive means that all possible events are in the sample space. Well, I want to thank you very much for your support on this video. I hope that you're finding these videos useful as you journey through and the introduction to probability theory. Again, in the mantra of the Hunger Games, may the odds be ever in your favor. And I mean that unless you and I are in the same event. If we're in the same event, then it's every man for himself. You have a great day.